Number 3 on the Module 6 practice quiz number 2. I ran out of space, so I'm going to do this on a separate paper. So I have the square root of 84, x squared y to the 7th. So 84 is not one of the ones with a perfect square root, but it does have a factor that has a square root. I know that it's divisible by 4, so let's do 4 times 21. Break that apart a little bit. And I have x squared. That's going to be able to have a square root because that's an even exponent. And then y to the 7th, that's an odd exponent. So I'm going to make it something with an even exponent. And there's 1 left over. Y to the 6 times y. That's still y to the 7th. So the square root of 4 is 2. That gets to come out of the radical. Square root of 21. The only factors are 3 and 7. It can't break down anymore. So that has to stay under the square root. Again, I'm leaving some space here for other things that might come out of the radical. And everything that has to stay in the radical will go over here. So the square root of x squared. So it's asking what times itself is x squared. Well, x times itself is x squared, so that is your square root. The square root of y to the 6th. What times itself is y to the 6th? Y to the 3rd times itself. You can write it like this. Y cubed times y cubed times itself is y to the 6th. And then we have the square root of y still. That doesn't have a square root, so it has to stay under the radical. And there's your answer. Number 4, we're doing a cube root this time. So the cube root of 128 x to the 7th y to the 9th. So 128, that's not a number that has a perfect cube root. However, it does have 64 as a factor. 64 times 2. That'll get you to 128. X to the 7th. So remember before we were trying to look at even and odd exponents, because if it were even, we could pull that out easily. Here we're looking for factors, or sorry, multiples of 3. So I could write x to the 7th as x to the 6th times x. And then y to the 9th already has, or 9 is already a multiple of 3. So I'm going to take the cubed root of 64. That's 4. That comes out of the radical. The cubed root of 2. That has to stay under the radical, because there isn't one. The cubed root of x to the 6th. So what times itself 3 times is going to give you x to the 6th? And that is x squared. Look at this. X squared times x squared times x squared. That gets you x to the 6th. So your answer to the cubed root of x to the 6th is x squared. And notice, that's the exponent of 6 divided by 3 gives you 2. The cubed root of x, that has to stay under the radical. And the cubed root of y to the 9th. Well, what times itself 3 times is y to the 9th? That's y cubed. Y cubed times y cubed times y cubed, because we add exponents. That'll get you y to the 9th. So y cubed times itself 3 times gets you y to the 9th. And that's your cubed root answer. Number 6. Which of the following are located between 5 and 7 on a number line? So we have 2 root 10 for part A. Root 10, very close to root 9, which is 3. So it's going to be a little bit more than 3. Let's say 3.1. And that multiplies that by 2. So we get about 6.2. Well, that's between 5 and 7. Again, if you would have approximated, say that to be 3.2, you still get 6.4. You're still going to get between 5 and 7. So even if you're off a little bit on your approximations, you're going to be just fine. Square root of 10, we just approximated that one. We could say 3.1 plus 4. We're going to get 7.1. So that's bigger than 7. What I want you to see is that this is bigger than 3. So if you add 4 to it, you're going to get over 7. So not that one. 13 minus the square root of 5. So the square root of 5 is very close to the square root of 4, which is 2. Just a little bit more, so let's say 2.1. And 13 minus 2.1, that's 10.9. That's definitely not between 5 and 7. Square root of 17 plus the square root of 6. Now this is close to the square root of 16, which is 4. Just a little bit more, so let's say 4.1 is our approximation. And the square root of 6. Now that's between the square root of 4, and the square root of 9. So between 3 and 4 for our answer. Maybe a little bit closer to 4, because x is closer to 4 than 9. So I'm going to say 3.4. So I have about 7.5. It's bigger than 7, so not that one either. I'm sorry, this should be 2.4. 6.5, I thought that was wrong. So this one actually is in between 5 and 7. All right, the square root of 30 plus 1. The square root of 30 is between the square root of 25 and the square root of 36. It's slightly closer to 25 than it is to 36, so let's say 5.4 maybe, somewhere in the middle. 5.4 plus 1, about 6.4. And that is between 5 and 7 on a number line. So you have A, D, and E.